As you all know, in any model we have two type of variables. One is dependent variable, means the target variable, and others are the independent variables. The target variable or dependent variable is denoted by y, and here y, let's have a look at our data. At the end of the project we have to forecast the demand, so this will be our target variable or dependent variable. So our y here will be data.demand. Okay, now we have to consider the independent variables, and independent variables we can denote with x. From this data frame, one variable is target variable, so our all other remaining columns or variables will be considered as our independent variables, and we will save this in a x. Okay, now to consider those remaining columns, we will simply drop the demand column from this data frame. Okay, here our data frame is considered. On this data frame I have used the drop function. Inside this drop function I have mentioned the demand column. Here we have to pass another parameter, x is equal to 1, because we are considering the columns here. Okay, when we will run this, the command has been executed, and if we have a look at our x and y, suppose this is our target variable, so this is y values, and our independent variables, these are our independent variables. Okay, to have a better look, simply write x here. So here if you notice, in x we don't have the demand column. Here I have written for your reference y as the target variable or dependent variable, and x as the independent variables or features or predictors. Now we will split the dataset into training and testing data with a ratio of 80/20, means our 80% of data will be our training data and rest 20% of data will be our testing data. First of all, we will create our xtrain equal to, and here we will consider this x data frame, this one, and we will use the log function. Inside this log function we will consider the records till end of 2023. That will be 80% of our total records here. So we will mention the date here, 2023 and December 31st. When we will run this, now have a look at our xtrain. This is our xtrain from 8th January 2020 till 31st December 2023. Now I will try to explain this xtrain here. Suppose we have this whole data frame including x and y. These features or these columns are considered as x, and this single column demand is considered as y. Now we have to split the data into a ratio of 80/20. We have the records from 2020 till 2024. So we have to split these records in a ratio of 80/20. So in our xtrain, if you see, I have considered from starting till 31st December 2023. So here we will consider from here, from starting 2020 and till the end of 2023, and all the x variables will be considered here, and this area or these columns will be our xtrain. I will mention here as xtrain. Okay, after creating this xtrain, now we will create the ytrain, and for this we will consider the y here, our target variable, and again we will use log function, and inside this log function we will start from our first row and till the again 31st December 2023, which is up to our 80% of dataset. And when we have a look at our Y train, it will look like this. It is from 8th January 2020 till 31st December 2023, this same date. Okay, now if we go again here we have this value from 2020 till 2023. 80% of Y column is considered as our Y train. Here we can simply write it is our Y train. Okay. Next we will create our testing data set, our X test and Y test. First create the X test. For this we will consider our X data frame. Again we will use the log function, and here this time we will use the data from starting of 2024 till the end of 2024. So here we have to mention our starting date, and our starting date will be 2024 and January and 1st January. Okay, when we will run this, here by mistake I have typed the testing dataset, but in actual it is training dataset. Okay, 80% is training data, so change it here, training data. Okay, and this is X test is our testing data, and it is 20% of the dataset. Okay, 20% of our dataset as testing data. Now if we go here again, this X test is this much area. Okay, from starting of 2024 till the end of 2024, it is 20% of our total X. And again I can write here X test. Okay, show the X test like this. It is considering from 1st January 2024 till 31st December 2024, which is our this dataset, and it is 20% of our actual dataset. Similarly, we will create our Y test. For Y test, we will consider our Y variable, Y dot log function, and on this log function we will mention again the date from where we want to consider, and we want to consider from 2024 and January 1st, and colon, after colon we will keep the blank to consider all the records till the end of this data. Run this, and this is our Y test from 1st January 2024 till 31st December 2024. This is our Y test. Okay. Now we have X train, X test, Y train and Y test. We can check the shape, print, and X train dot shape. It is total this one, and similarly Y train shape, it is this one. Okay, and similarly we can check the shape of test dataset, X test and Y test. It is our 80% of data, and it is our 20% of data. Here we have 34,892 records and 14 columns, while in Y train we have only 34,000 records and there is only single column, which is Y itself, so it is blank here. Similarly, here we have 14 columns, and in Y test we have single column, the Y itself. Now we will use the XGBoost model here for the forecasting, because the reason is simple. XGBoost is a powerful algorithm for the time series forecasting, as it can handle the non-linear data easily, and it can also handle the seasonality and trends in the time series data effectively. First of all, from XGBoost library we will import a class known as XGBRegressor. XGB, it is running here. The command has been executed. In simple terms, you can say from the toolbox, which is XGBoost here, we are importing a tool which is XGBRegressor. It is a class and it is designed for the problems where we have to predict a continuous numerical value. Next is from sklearn library, we will import two fundamental metrics, and first one is our mean squared error metric, mean squared error, and our second fundamental metric is mean absolute error, mean absolute error. These two metrics are used to evaluate the performance of our model. We will run this again. The metrics are imported now. Next is from the sklearn library, we have a module called model selection, and from this module we will import a class, the TimeSeriesSplit, and run this, and the class is imported now. This TimeSeriesSplit class performs appropriate cross validation when we deal with the time series dataset. Next, we will initialize and train our XGBoost model with some specified sets of hyperparameters. Start with model XGB, and here we will make use of this XGBRegressor class, XGBRegressor, and here we will pass our hyperparameters. Our first hyperparameter will be nestimators, Here we will set the number as 1000. This hyperparameter nestimators defines the number of trees that the model will build. Here the range should be from 100 to 1000 only, because too high range will lead to a problem of overfitting, while too low range will lead to a problem of underfitting model. The next parameter we have here is early stopping rounds. And we will set it to a value of 50. This is a regularization technique that helps prevent overfitting of the model. Our next hyperparameter is learning rate, and we will set our learning rate at 0.01. The learning rate, denoted by this symbol, is a hyperparameter that determines the step size taken during the optimization process of the model. In simple terms, the learning rate determines the contribution of each individual tree to the final prediction. A smaller learning rate might be slower, but it will show more accurate updates, while a higher learning rate can speed up the training but may lead to the overfitting problem. Our next parameter is random state. The random state, and we can set it as 42 here. Setting a random state ensures that the same sequence of the random numbers is generated each time the model is trained. Our next parameter here is objective, and we will set it like regression and squared error. This parameter specifies the loss function to be minimized during our training. And this item, regression squared error, here indicates that the model is being trained for a regression problem, where the goal is to predict a continuous numerical value, which is our demand column or the target variable. And now we will run this. The model has been initialized. In short, we can explain this above code like this. The XGBRegressor initialization creates a model that will train up to 1000 boosting rounds or 1000 trees, but it will stop early if the performance on a validation set doesn't improve for the 50 consecutive rounds, which are decided by our hyperparameter early stopping rounds. Next, each tree contribution is scaled down by a learning rate of 0.01, means the learning rate is set as 0.01 here to prevent the overfitting of the model. And at last, this model is designed to minimize the squared error for the regression task. Now let's start training our model. Here model XGB.fit function we will use. Inside this function, first of all we will pass the xtrain, then we will pass ytrain. Xtrain and ytrain we have defined above. The next parameter is to provide the evaluation sets, and eval set equal to, and this parameter provides the evaluation sets that XGBoost model uses to monitor the model's performance during the training. Here we have two evaluation sets. First one is xtrain, ytrain, and the second set is xtest and ytest. This is our first evaluation set and this is our second evaluation set. And the last parameter we can set as verbose equal to false. Setting the verbose equal to false means we don't want to see the model running here, or we don't want to see any message during its running process. And we will run this now. The model is been running. So this is the output, and our model is ready now for the prediction tasks. Let's create a variable that will store the output of our prediction, and this variable name can be of your choice. I am naming it as prediction XGB. Now I will make use of my model that I trained above, model underscore XGB, and on this model I will use the predict function to make the prediction, and this time we will predict the data from xtest. Okay, now we will evaluate our model with these two evaluation metrics that we import here, mean squared error and mean absolute error. So I will create my first variable root mean square error for this XGB model, and here in this I will make use of NumPy library to make the square root of our first matrix mean squared error. I will copy from here mean squared error and paste here only like this. Okay, and here in this we will have our ytest and our predictions, this prediction variable. Second, I will create another variable mean absolute error for this XGB model, and in this I will make use of my second matrix mean absolute error. I will copy this and paste here, and inside this we will make use of ytest and again this prediction variable. We will run this. The command has been executed. Now let's print the result of RMSE and MAE
So like this. Okay. So our RMSE value is coming about 167.67, while our MAE, mean absolute error, is coming about 125. Here the RMSE value is higher than the MAE value, which is a common occurrence. Now the final step is we will visualize our predictions. Using Matplotlib library, first set the size of our figure. Here we will draw two different plots, one for the actual demand and second plot for the our predicted demand. So plt.plot, first create a chart for our actual demand. For this, on x-axis we will consider our index from the y-test, okay, and on a y-axis we will consider the values from y-test, and we can also give the label to this chart like actual demand, and let's give a color, suppose blue. Now if I run this, then it will show the output like this. We can use plt.show here. Okay, so this is our actual demand in our testing dataset that starts from 1st January 2024 and end at December 2024. Next we will plot the predicted demands. So plt.plot, on x-axis the values will be same, y-test, index, but on y-axis this time we will mention the predicted values, and our predicted values here from this one. So I can simply copy this and paste here. Okay, and we can also give the label. Let's set the label as XGBoost predicted demands, or you can say simply predicted values or predicted demand, whatever you want to choose. And this time we will give the color to red to differentiate easily. And when we will run this, you can see the blue color we have the actual demand, while in red color we have the predicted demand. And we can change the line style of this predicted demand. Suppose we can give it as ##. Okay, like this. We can also give the title to this plot, plt.title XGBoost electricity demand prediction. Running this is our title. We can also mention our x label and y label. Suppose our x label is, we are setting as date because date is mentioned here, and on y label we are mentioning the demand. Running this, here we have date and here we have demand. We can also set the legend here, plt.legend, okay, legend function. So here we have the actual demand denoted by blue color, while the predicted demand is denoted by the red color. From here we can easily notice that our predicted demand values are approximately equal to the actual demand value. So means this model is working well. Finally we will save our model, and to save the model we will make use of the Joblib library, and we will import this, import Joblib. Okay, from this Joblib library we will use the dump function. Inside this dump function we will pass our model name, and our model name here is model_xgb. We can copy and paste here. Next we have to mention our file name. I am giving file name as electricity XGB prediction model. You can name anything, and here we will use the extension PKL. Okay. When we will run this, the command has been executed and it is showing the output like this. We can locate this file on our computer system. Here, if we see in this folder, we have this model, electricity demand XGB model.pkl extension, and it is showing that the type is PKL file. PKL is the short form for Pickle file. Now, whenever we want to use this model for prediction, we can simply load this in this Jupyter notebook and use this. And this is how we can load this model. Using the Joblib library, we will use the load function. Inside this function, we will pass the file name, the Pickle file name that we saved above. Okay, so that's how we can load this model, and the model is loaded. And if we run this, it will show the output like this. Okay, so that's all friends for this video. I hope that you have learned too many things from this project and you will implement this project in real time. Thanks for watching.